So welcome to my class in continuation with Unit 3, Statistical Tools and Their Interpretation. We finished with measures of central tendency. We are doing measures of dispersion. We're going to finish them off too today. And in measures of dispersion, we talked about range, we talked about quartile deviation, we talked about mean deviation, we talked about now standard deviation. And we've done all the series with the different methods. So right now, standard deviation, we finished with the individual series, we finished with the discrete series, we are on with the continuous series. And in this, we've finished with, in continuous series, we finished with the actual mean method, the direct method, we talked about the assumed mean method, that's finished. And right now, we're going to talk about the step deviation method. So we go on for step deviation method when, of course, here the values are not very big. When the values are very big values, then it becomes easier to convert the whole thing into step deviation method, so that calculation becomes very simple. So let me also tell you that, let me tell you standard deviation. We talked about the ungrouped data, which was individual series. Standard deviation, discrete series we finished with. Now, in the group data, there is also continuous series, which we are doing. We finished with actual mean method, the direct method in the continuous series, the shortcut method in the continuous series. And in this class, we are doing the step deviation method. I've taken the same numerical, the same illustration. So marks are given as 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. And these are the number of students, 2, 4, 4, 8, 6, 60 to 70. So many number of students got so many marks, and 2 students got between 70 to 80 marks. So this is how I put it down. So once I write down the marks, again, very important thing is you have to find out the mid values. So again, how do you find out the mid values? You take the lower limit plus the upper limit and their average. Find out the average divided by 2. This is how we do it. 15, now 20, the lower limit plus the upper limit 30 divided by 2 is how much? 50 divided by 2 is 25, and so on. So that's how we get. Now in this, it's very important to find out the deviations from an assumed mean. So in this case, we've taken 45 as assumed mean. You can take any. You could even take 35 and do it. So we've taken 45. Now, what we have to do is we have to bring down the values by a common factor. In this, the common factor I've taken is 10, which is divisible by each of these values, the deviations that I've obtained. Like for example, 15 minus 45 is equal to 30, minus 30. So minus 30 divided by 10. 10 is divisible by in 30, so I get minus 3. In the same way, 25 minus 45 is minus 20 divided by 10 is minus 2. 35 minus 45 is equal to minus 10 upon 10 is equal to minus 1. Then I get 45 minus 45 is equal to 0. 55 minus 45 is equal to 10 divided by 10 is equal to 1. 65 minus 45 is equal to 20 divided by the common factor 10 is equal to 2. 75 minus 45. 75 is again mid value minus assumed mean is 45 is equal to 30. So m minus a is 30 divided by the common factor 10. I get 3. Now what I have to do is the next step is the frequencies. Here are the frequencies. Now the importance of frequencies, they come into play. Now I take the corresponding frequency and multiply it with the deviation. Okay, so and I put it as d dash. Deviation which has been brought down by a common factor. So f into d dash. 2 into minus 3 is 6, 4 into minus 2 is 8, then again 4 minus 1 is into is 4. 8 into 0 is 0. 6 into 1 is 6. 3 into 2 is 6. Okay, and 3 into 2 is 6. So this is how. So I have to, what is important is I have to get sigma fd dash. I've got to put it as whole square. Now what do I do? So 6 plus, this is 18 and this is also 18. So I get a 0. Okay, so this is plus 18 and this is minus 18. So it cancels out and get a 0. Okay, now another thing what I have to do is, now I've got to get f into d dash square. I can do two things. I could have square d dash square. Okay, like for example, minus 3 into minus 3, 9. 9 2s are 18. I could have done that. But there's another way of doing it. F into d dash square can be f into d dash into d dash. So 6 3s are 18. Then 8 into 2 is 16. That is f into d dash into d dash. So 4 into 1 is 4. 6 into 1 is 6. 6 into 2 is, that is fd dash into d dash is 12. That is fd dash is 6 into 3 is, that is d dash is equal to 18. Then I add them up. I get sigma f into d dash square because I have to use this in this particular formula. Sigma f into d dash square divided by sigma f. Okay, so now just put the values. So sigma fd dash square is 74, so I put it as 74. And then what is this? 29. Sigma f is 29 minus 0. Sigma fd dash is 0 upon 29, the whole square, into C. Very important.